Welcome to a lesson with Dr. Powell. Let's take a look at the function 2 to the x and think about its derivative. All right, but to do that, let's play off of the derivative of e. We can rewrite 2 to the x in the following way. First, let's rewrite 2. 2 is e to the natural log 2. Do you see why? Because e and natural log are inverses of each other. And when you plug an inverse into another one, so you put it in the input slot of this function, e to the x, then it undoes what the other one does, and you end up getting back where you started with 2. So that's simply 2. So we can rewrite f of x equals 2 to the x as f of x equals e to the natural log of 2, and all that raised to the x. Okay, so we have this function is equal to that. Well, okay, how does that help us? Okay, well, let's think for a minute. This is e to the, in fact, maybe we can write x times natural log 2. Okay, just kind of keep that right there. All right. Well, let's proceed and see if we can play with it a little bit. So if we want to find the derivative of this function, we think f of x plus h minus f of x all over h. But we're going to use this form of f of x. All right. So we're going to get e to the x plus h. Oops. Okay, there we go. So e to the x plus, so x plus h times natural log 2 minus e to the x natural log 2 all over h. Okay, we're going to distribute this natural log 2 through here. All right, so we have h, and then we have, see, x natural log 2 plus. And notice with this plus here, addition in the exponent becomes multiplication right here with the same base. All right, we can factor out this e to the x natural log 2. So let's do that. We get e x natural log 2 factored out. We have e h natural log 2 minus 1 all over h. And we can think of this as being on the outside if we want. That's fine, just this times that fraction. Now, and we're taking a limit as h approaches 0. Now, notice that this goes to 0. Be nice if this were the same thing, because then we could use the idea that e to the u minus 1 over u, as u goes to 0, goes to 1 by definition of e. Well, why don't we just put it in? Just put in natural log 2. But the trade-off is you have to multiply by natural log 2. Notice that this whole thing right now will go to 1. Then we have a natural log 2 out here. And what's this? Now remember what this was. This was the same as this, which is the same as this, 2 to the x. I mean, you could work it backwards. I guess you could use a property of exponents, put that x up there with the 2 to the x, and you have natural log e, and you get 2 to the x. So basically, you get 2 to the x times natural log 2. So the derivative of f of x equaling 2 to the x is natural log of 2 multiplied by 2 to the x. Now, was 2 special in all of this? I mean, 2 kind of stayed there. If I could just replace all the 2's everywhere with 3's, or really any positive number for that matter, something I can plug into natural log 2, and I would get that the derivative of 3 to the x is natural log 3 multiplied by 3 to the x. Similarly, the derivative of even e to the x is natural log of e times e to the x, but that should be pretty clear. Natural log of e is just 1, right? So we get, just as we had before, the derivative of e to the x is e to the x. And in general, the derivative of a to the x is simply just natural log of a multiplied by a to the x. Thanks for watching.